Okay, now we're going to use the MGF to find the mean and the variance of a binomial. It's not the easiest way, but it's a use of the MGF, so we'll do that. And the second thing I'll do is I will again find the mean and the variance, but using a function of the MGF, specifically the log of the MGF. And that bit's optional, right? Okay, so let's recap. For the MGF of a binomial, we have this. It's a Bernoulli MGF raised to the power of n Charles. The first moment, otherwise known as the first non-centered moment, is first derivative of the MGF evaluated at t0. Now, first derivative. Look at it. I'm going to need the chain rule. So n comes down. I write the thing in the brackets. And I multiply it by the derivative of the stuff in the bracket with respect to t. Let's just recap. D by dt, something like e to the at is equal to the ae at. Just know that. Right, so we have here p e t. Oh, let's just tidy this thing up. N p e t times, and just so that simplifies working for the second moment, let's call this stuff in the whole bracket, let's call it something. What shall we call it? Let's call it k. No, let's not. Let's call it L. Okay, let's call it L. That's an arbitrary kind of choice. L. Okay, there you go. So that's the thing. That's what we've got. Therefore, expected value of x, first derivative of MGF value at t0, and np times e to the 0, that's 1, e to the power of 0, and then times L. L is all this lot, 1 minus p plus p times e to the 0, so that's 1. These p's cancel out, so that's just 1, so it's np. N times p times 1, np. Next, to find the variance we need the second moment, otherwise known as the second non-centered moment, and that's the second derivative of this guy, respect to t value at t is 0. So going through the same motions, but we're going to get more and more notation coming here, so we've got to kind of just be careful. There's a product rule here, right? So that L here involves t, the outside involves t. The NP's come out as a product, so we can just imagine that we're just doing this stuff here for the product rule. NP, let's open big bracket so we know we're just doing this guy. Let's write this guy down first, and let's do derivative of this guy with respect to p. Well, something looks wrong here. Something looks wrong because earlier I missed n minus 1. N comes down, n minus 1. Yes. Okay, so let's say L to the power of everything in that bracket is L to the power of n minus 1. Right, still works, everything else still works. Okay, now, so I'm going to do the derivative, so I've kind of written this thing down, I'm looking at derivative of this guy. So what I have is n minus 1 times L to the power, subtract 1 off that power, and now times the derivative of inner bracket respect to t, so that's going to be p e t again. That's right. Plus, and then now I'm going to write everything in that bracket. L n minus 1. I'm going to look at derivative of this guy with respect to t. That's just going to be et again. Okay, so that, now is that right? Okay, Notice that if you're uncomfortable with me using the L here, you can write this thing out every time you see place where you see L, but that kind of makes you're working longer. And always you try to kind of avoid writing stuff, kind of repeated stuff down line after line, because the more you have to write, increase the chance of making an error that's going to carry through. Okay, but on the other hand, if you use L, you must know that L contains a function of t, right? So for that reason, let's put this on the side as well. Instead of using L, I could put LT to force myself to think that L is a function of t. Okay, that's another way around it. Optional anyway. Okay, now, so we can now finish. Therefore, second moment is this MGF, second derivative evaluate at t0, np bracket e to the 0, that's 1, dot n minus 1, l to the n minus 2. We can see that's L here. If e to the t is always going to be the same. L to the 0 here, you can see if we put t in here, it's always going to be 1, isn't it? Always going to be 1, so we could have kind of made that note for all the working right through. So that's going to be 1 times p to the e0 is 1 plus, now we know that's 1 times, that's 1. So what do we have? We have, taking this through, we have n minus 1p squared plus np. Now we haven't finished because we're after the variance, right? But after that long slog, you might kind of think across the finishing line, but no, you haven't finished across the finishing line yet. Finally, the variance of x is equal to the expected value of x squared, second moment, minus the first moment all squared. Substitute what we found, so that's n minus 1 p squared plus np minus first moment all squared, n squared p squared. Now terms will cancel, multiplying out brackets, n squared p squared minus n p squared plus np minus n squared p squared. Right, np, let's just get these the right way. P at 1 minus p. Done. Otherwise known as, if you want to call this q, probability of, put in brackets, probability of failure, q, like that. Okay, either one's fine. So I've just shown you how to do this, using the MGF to find the mean and variance for the binomial. Not the most efficient way, not the kind of shortest way to get this, because you wouldn't use the MGF to do this. But if you had to, that's what you would do. Okay, to finally finish, for those of you interested in my second years, is that we can find the mean and variance using a modification of the MGF, which in some instances lead to quicker, and I know you kind of like quick kind of things, quicker way to reach the mean and the variance. Well, not mean, but the variance, okay? Here we go. Instead of